How's it going, everybody? So right now we're going to cover 3.4, titled the chain rule. One of the more important rules in the world of derivatives. And so we've covered a number of different rules at this point. The power rule, the quotient rule, the rule of sums, the rule of differences, right? But right now we're covering the chain rule. And basically what the chain rule does for us is it allows us, I think I hit pause there, it allows us to evaluate a function that in many ways is the composition of two functions. So it would be an example like this. So if we had f of x equals the square root of x squared plus 1, it's going to allow us to figure out the derivative of a function like this. And until this point we don't have any tools that can help us to do that. So basically at the end of the day, when we are calculating the derivative of a function like that, it is, like I said, the composition of two functions. And what I mean by that is this: f of x equals f of g of x, right? Or we would write it like this, okay? So to solve for f prime, in that case where we have the composition of functions, it would be the derivative of f of g of x times the derivative of g of x, okay? So what we're going to do now is we're going to work through that, and we're going to use an example. And what I want to do is, I thought I could do it. You know what? I'm gonna pause the video and then I'm going to come back so that I can do it out. So like I said, what we have here is we have the composition of functions, and I'm going to show you what I mean by having the composition of functions right now. So for example, if we were to say that f of u happened to be, let's see here, so f of u is going to equal the square root of u, all right? And then we say that g of x is going to equal x squared plus 1, all right? And basically, what we need to do is we need to compute the derivative using the chain rule. In our understanding, essentially that, and I'll write it up here, f at x is equal to f of g of x. These are just two different ways to write it, or f of g at x, okay? And what I want you to understand here is basically this function is this function as the base function. This is f of x. And then what's inside is g of x here, okay? So in order to do this appropriately, in order to calculate it, if we were to take a look at the, let's see here, the chain rule definition. Basically, the chain rule definition tells us that, f prime of x, which is in relation to this, okay, is going to equal f prime of g of x times g prime of x, okay? So first I want to calculate f prime of g of x. So if I'm going to calculate f prime of g of x, I first need to figure out, well, what is f prime of u? Because that's essentially what this is. I need to figure out what f prime of u is. So, I'm going to put this all below it here and I'm going to fill it in. So, figuring out what f prime of u is basically going to tell me, well, what's the derivative of this? Well, we can say that u is this, the square root of u is the same as u to the 1/2 power. And this would be the power rule of derivatives. And what we do is we take the 1/2, we move it down, and right? And then what we do is we subtract 1 from here, which is going to give me negative 1/2. Okay? So essentially what I did was I figured out what the derivative of this is here. Now I need to figure out what the derivative of g of x is, which should be a little bit easier. We know the derivative of a constant is just 0, but the derivative of x squared is going to be 2x, and then we subtract 1 from there, which is going to give us 1. So really, the derivative of g prime of x, which is this, or the derivative of g of x, or g prime of x, is going to be 2x. So, and remember, we're multiplying these two pieces as we go down here, right? So I'm getting all the way to the bottom here, and what I really have is 2x. So now, if we want to simplify this, what we can do is, since we have a negative exponent, we can take this and we can put it in the denominator, right? And what we're going to have here is we're going to have 1 over 2 root u times 2x, okay? And, when we do that, we can now take what our g of x is, and we can now plug it back in for u. So what I'm going to have is, 1 over 2 times x squared plus 1 times 2x. Okay. Make sure we can get this all here for you. I'm going to zoom in on it. And then we're going to multiply, and we end up getting 2x over 2 root x squared plus 1. The 2's divide out, and at the end of the day, I end up having x over the square root of x squared plus 1, which essentially is my derivative. Pull it up now so we can see the whole thing, okay? Which is going to be my derivative of f prime, or of the function, not of f prime, but of the function f of x equals the square root of x squared plus 1, okay? Okay, so the next slide that I want to take a look at is this slide 11 that talks about the chain rule in more detail, but now it's combining the chain rule with the power rule, which in some ways was kind of what we did in the previous example. But if you take a look at this key concept here 4, it shows us, and it basically reviews the chain rule, or the power rule right here, and then now it's applying it here. So we had a square root before, now we don't. We have g of x to the nth power, and basically in order for us to find the derivative of this, we would then, take the n, we'd put it in front, we'd subtract 1 from it, and we'd have n minus 1, right? But then we also have to multiply that by the derivative of g of x. Remember, this is a composition of functions. A composition of functions in the same way that we worked with before. Okay, so let's take a look at this example here. Given the equation y equals x cubed minus 1, all raised to the 100 power. And essentially what we need to do is differentiate this. Now remember, in order for us to do that, we need to recognize that this is in fact the composition of functions. And if we look at f at g of x, one could say that given f at g of x, that the function f is really this whole concept of u to the 100 power, right? That could be that f of x function, and the g of x function would be just x cubed minus 1. Now there's another way that we're going to do this, and we're going to take a look at it using the dy dx and dx and ddx to figure it out. So basically, if we set u to be what g is here, all right? So g is this entire piece here, kind of like what we said, right? And then we're going to go ahead and say that n represents your value of 100. We're going to go ahead and solve this. So basically the derivative, dy dx, is going to equal the derivative of this entire function with respect to x. In order to do that, we need to take the derivative of the large piece. So just simply the derivative of this. The derivative of this is we take 100, we bring it down in front. We have 100 times x cubed minus 1. And then remember, we raise it to the 99th power. And now we're going to go ahead and we're going to multiply it by the derivative of g of x, all right? Or the derivative of, so we would say d dx. And what is g of x? G is x cubed minus 1. Okay, so we're doing it in 2 steps kind of here. So as our second step, we have 100 times x cubed minus 1 to the 99th power times the derivative of this. Now, if we remember, the derivative of negative 1 is just 0. So we're really just taking the derivative of x cubed, which is going to be 3x squared. You take the power, you put it in front, you subtract 1, and there you go. And now all we need to do is really multiply these two things together. 3x squared times 100 is going to give you 300x squared times x cubed minus 1 to the 99th power. And there is our derivative of this function.